Okay, so these are extension notes for lesson 1 on solving quadratic functions by factoring. This is specifically focusing on word problems, and you do not have to take these notes, but I think they might be beneficial if you have trouble with word problems. So again, these are optional notes. You must have the other notes for class, so do not take these ones instead of the other ones. But I'm going to go through these regardless in case you find it helpful. So I'm not going to write our objectives, but going to instead jump right in with the word problem. So we have our first example, which says the area of a rectangular window is 40 feet squared and the width exceeds the height by 3 feet. Find the dimensions of the window. So what I usually do first is draw a visual. So you can see here, I've drawn out the visual and labeled what I know in that diagram. So I'm calling the height h, the width w, and I know that the width is equal to the height plus 3. The area is 40 feet squared. And so the next thing I do, though that might be hard to read, is I'm going to determine the relationship between my variables. So I know w is equal to h plus 3. I know the area is equal to the width times the height. So I'm setting up these relationships because I know that those things connect all the information that I'm given and what I'm trying to solve for. So I know the width, like I said, exceeds the height by 3. So I do height plus 3 to get my width. I know the area of a rectangle is the length times the width, or in this case, the height times the width will give me that rectangle, so I write those down, and now I'm going to define my variables. Width is w, height is h, area is 40, and then I'm going to substitute them in. So now I have 40 is equal to my width, h plus 3 times h, my height. So now I have an equation in terms of one variable, so I can solve out for h. I know I'm going quickly through this, so if you need to pause and make sure you have this all down, please do so. But continuing on, I'm now going to solve out for h, and so I need to first do that by distributing my h value into those parentheses. And I get 40 is equal to h squared plus 3h. Now I'm at the point I have a quadratic, I can solve out for h. So referring back to our previous notes, I know to solve for h when I have a quadratic, I need to set my equation equal to 0 to start. So I'm going to subtract 40 from both sides, and I get h squared plus 3h minus 40 is equal to 0. And now I have a factorable expression on the left side. So I'm going to factor the left side by finding factors of negative 40 that add to negative 3. I'm finding factors of negative 40 that add to negative 3. I know since a is 1, I'm putting h first in both my binomials, and the factors are going to be positive 8 and negative 5. So I end up with the factored equation h plus 8 times h minus 5 is equal to 0. Then I use the zero product property to solve out for h by setting, because I know when I'm multiplying these two terms, and since they're equal to 0, one of these two terms must be 0. So I set h plus 8 equal to 0 and h minus 5 equal to 0, and then solve out for h in each expression. So h minus 8 and h minus 5 are my two answers. But if I think back to the problem, it's asking me to find the dimensions of a window. It is not possible to have a dimension of negative 8 feet. So I know that that solution is not going to work. It is extraneous. If you remember that word from our first unit, it's an extraneous solution. So my solution is actually going to be h equals 5. So I chose the solution given the context of the problem. Now I need to actually solve out for, it didn't just want the height, it wanted the width and the height. So I solve out for the width by adding 3, since I know the width is 3 greater than the height, and I get 8. So my dimensions are 5 by 8, so I solve for my other dimension. And then my last step is going to be to write my answers as a sentence. So I do that by saying the height of the window is 5 feet and the width of the window is 8 feet. And then I am done. We're going to go over one more together, but make sure you write down any questions, comments, concerns, or clarifications on this example, and have this all written down. I'm going to flip the page. So for this one, again, we have another example. We're framing something else. So we have a frame for a picture with the dimensions of 24 inches by 16 inches that have a, and I have 276 inches of framing material. So I'm trying to frame a painting that's 24 by 16 inches, and I have 276 inches squared of material to frame it. How wide should my frame be? So again, I'm not gonna write all the steps out for this one, but I'm gonna show you the same order. So I'm gonna start by writing out drawing out my visual. So I have my original painting in the middle and then the framing goes around. I know the width of the frame that it's asking about. So how wide should my frame be? It's going to be the surrounding border, so they all would be equal to W. So then what I need to do is figure out, how can I figure out, since the question is really asking me how wide should this frame be, it's asking, I know the area of this part because it tells me I have 276 inches squared of material for that border. So ultimately my goal is going to be to set up an equation that gets the area of that border so I can set it equal to this and solve out for my width value. So my goal is to write an equation for this shaded area so I can solve out for width. So to do that, as you can see from some of my other notes, I'm going to start by finding the area of this whole rectangle and then subtracting the area of this inner rectangle. So this was very similar. This is more or less identical to one of the problems you saw in your performance task for last unit. But we're going to find the area of the whole thing and subtract the area of the inner thing so I can just be left with the border. So to do that, first I need to find the whole side here, and I know this is 16 inches, but then there's a W on either end here that I need to account for. So that's W and W, that's 2W plus the 16 in the middle gives me 2W plus 16 for that side length. And then similarly for the bottom, I'm going to have 2W for these ends and then the 24 in the middle, so I have 2W plus 24. I know if I multiply them, it'll give me the whole area of that rectangle, so length times width gives me the whole area, and then I'm just going to subtract 16 times 24 to take up that middle part. So the equation I end up with is 2W plus 16 times 2W plus 24 minus 16 times 24, and I know that what's left in that area will be equal to 276. So the hardest part is done. We've solved out, or we've written our equation. Now we just need to solve it out for W. So to do that, I'm going to first distribute. So I distribute in and calculate that out, and I get 4W squared plus 48W plus 32W plus 384 minus 384 is equal to 276. So if you notice, the 384 cancel, so the positive and the negatives cancel each other out. These combine to 80, and I'm left with 4W plus 80F, sorry, W, I don't know why I used F, is equal to 276. So then I know I have a quadratic, but it's not equal to 0, so I need to move my 276 so that I have a quadratic that's equal to 0 that I can solve out for. So I subtract 276, and I get 4W squared plus 80W minus 276 is equal to 0. Now I have an expression. Each term is divisible by 4, so I'm going to factor out a 4 next to simplify my quadratic. So I get 4 times W squared plus 20W minus 69 is equal to 0. And now I'm going to factor what's left inside the parentheses so I can solve by factoring. So if I factor what's left, I'm finding factors of negative 69 that add to 20. I know since my A value in the parentheses is 1, I'm going to put a W first in each set of parentheses. So I end up with 4 WW and then positive 23 and negative 3 multiplied to negative 69, but add to positive 20, and they're equal to 0. Now I use the zero product property, so I know since I'm multiplying these three terms and they equal to 0, one of them has to be 0. 4 obviously can't be 0, so either W plus 23 is 0 or W minus 3 is 0. So I set each expression equal to 0, solve out for W in each, and I get W equals negative 23 and W equals 3. Again, we can't have negative inches for a frame width, so that is an extraneous solution. So I'm left with W is 3. So last but not least, I'm going to write my answer in a full sentence, and I get the answer. The frame should be 3 inches wide. All right, that's all for that. Make sure you write down any questions, comments, concerns you have on it so we can go over it together in class.